Hey, how's it going, third grade? It's Mrs. Lee. I'm excited to do another math video with you today. We are going to spend our time talking about growing patterns. But before we get started, let's do a quick review of repeating patterns, okay? I'm going to switch over to my document camera and we'll get started. All right, so in front of you, you have a repeating pattern. Do you see that? It is white, white, brown, yellow, white, white, brown, yellow, white, white, brown, yellow. The part that is repeating is the white, white, brown, yellow. So we have created this pattern and we've identified it as a color pattern, and now we need to describe it as a letter pattern. Does everybody remember how you do that? Let's talk about it real quick. Sorry, I'm reaching for a sheet of paper so we can do that together. Remember, when we transfer a repeating pattern from its color pattern to a letter pattern, all we do is assign a letter for each new part of the pattern. So we start with the letter A. Every white cube is going to be A. Brown is a new color, so it gets the next letter, which is B. Yellow is another new color, so it gets the next letter in the alphabet, which is C. And this just repeats over and over again. Every time there's a white cube, it gets A. When there's brown, it gets B. And when there's yellow, it gets C. So this can also be described as an AABC pattern. AABC, AABC, AABC. So we've taken this pattern right here, the color pattern, and we have transferred it to a letter pattern, which is another way we can describe it. Now, another thing with repeating patterns, just as a quick review, is we have to identify the core of the pattern so that we can extend it. And what I mean by extend is take what we already have and make it longer. All right, so let's look at what we have that repeats over and over and over again. You can tell between my letters and my colors that AA, and I'll get my hands out of the way in just a second, AABC is the part that repeats over and over and over again. So to extend it, I need to add the core, which is the repeating part, to the end of my pattern. So making this pattern longer, I would take two more white ones, a brown, and then a yellow, which is the core, and add it on to the end. So now my repeating pattern is even longer because we have identified the core and extended it. So remember, with repeating patterns, you need to create them, then you need to identify them, you need to be able to describe them, and extend them. So good review with that, everybody. And now let's jump into growing patterns. What happens when something grows? It gets bigger, right? Well, that's exactly what a growing pattern is. And when we work with growing patterns, we work with objects, we work with pictures, we work with tables, and we work with numbers. And that's where we're getting started today. So I want you to know that in a growing pattern, something changes from each step to the next. And that's how we figure out what the growing pattern is. It is also how we figure out what the rule is. And that's going to be really important as we work together and figure these patterns out. So let's just jump right in and look at this first number pattern. As you can see, it goes 4, 10, 16, 22, 28, 34. And I have to figure out what comes next. Well, in order to do that, I have to determine the difference between these two numbers. And I can think of the word difference as in subtraction because I can use subtraction, but I can also think in the word difference as in what is different between the two of them. Okay, so let's see. I go from 4 to 10. What happens to 4 for me to get to 10? Can you think? Well, it's growing, it's increasing. So for me to get from 4 to 10, I need to add what? 6. And there's my plus sign right there, plus 6. Let's see if this works all the way along this string of numbers for me to fill in right there. So the next steps in my pattern go from 10 to 16. Well, yeah, 10 plus 6 is 16. I think we're on to something. 16 plus 6 more, yes, is 22. 2 plus 8, to get from 2 to 8 is also a plus 6. So I can just apply that to 22 to 28. It's still working, plus 6. So 28 to 34, also plus 6. So now this is where I have to figure it out. 34 plus 6. What is going to be the next term in my pattern? Did you hear that word I just used? Term? Well, that's what this is. Each part of the pattern is called a term. So here we go. 34 to here, to the term I need to figure out, is a plus 6. So it is 40. That is what would complete this number pattern. Okay? The rule along this pattern, what rule did we follow the whole time? Plus 6. Nice job, third grade. Let's move on and try another one. I want you to notice something about this pattern right away. Sorry, let me grab it. Here it is. What do you notice about the numbers? They're getting smaller. Well, the change in a pattern can be increasing, like it was in this one. But the change can also be decreasing as long as it decreases by a constant value, has a constant change. So let's look. I go 54, 51, 48, 45, 42, 39. Can you think what's going on right here? Can you figure it out already? What's the difference between 54 and 51? Well, 54, if I count backwards, 53, 52, 51. Is it a minus 3? Well, let's see if it works from 51 to 48. So 51, 50, 49, 48. Yeah, it looks like that the minus 3 is working. 48 to 45. Well, I know that from 8 to 5 is minus 3. 8 minus 3 is 5. So 48 minus 45 is or 48 to 45 is a minus 3. It continues here, minus 3. Yep, still a minus 3. So I have to get from this term to the term I'm trying to figure out. You think you know what it is? Well, it would be 39 minus 3, which is 36. Way to go, third grade. So to figure out the last term in this pattern, we followed the rule of minus 3. All right, I have a couple more number patterns for us to work on together, and then we're going to move on to something different. Now, this pattern, I want you to notice how many gaps I have. Okay? Do you notice that I just don't have to figure out what comes next? I might be asked to figure out what is the 8th term in the pattern, not just what's next, but one that's further down the line. And in order to figure out what the 8th one is, I have to figure out sorry about this if you can see these pop-ups. That's just from my computer. I don't even know what it is. Okay, if you can't see them, sorry, I just had a pop-up on the side. But anyway, if I have to I don't always have to figure out what comes next. I might be given a specific term. So in this one, we have to figure out what comes 8th. I have my first, second, third, fourth, but in order to figure out the 8th, I also have to figure out the 5th, the 6th, the 7th, and then finally I'll get to the 8th. So let's see what's happening in this numeric growing pattern. All right, so from 24 to 31. Anybody you think you know what it is? 24, 25, 26, 27, 28, 29, 30, 31. Looks like a plus 7 to me. This one is easier for me to see. 31 to 38, I can clearly see that plus 7. But I know if I need to follow that rule, I need to follow that rule to get to the 8th position. So 38 to 45, yes, a plus 7. 45 to here, plus 7. 40, 45 plus 7. Anybody know? If you said 52, you are exactly right. Now I got to do 52 plus 7. What is it? Right on the money. It's 59. Now 59 plus 7. You think you got it? 66. And finally, that takes me, I had to figure all those out to figure this one out. What's 66 plus 7? This final term, I'm going to mark out my question mark. I don't need it anymore. It's going to be 73. Okay, so remember, in this one, I didn't have to just figure out what's next. I had to figure out my pattern, and I had to figure out the 8th term. So make sure you're reading your pattern questions very carefully. All right, you may see when you have to figure out a term in a pattern, this is close to what we just did. It might not always be the last one. You might not be told to go out to the 7th or 8th term and figure that out. Sometimes there might be one right in the middle of a pattern. So let's check out what's happening here. First of all, the values are decreasing. That means they're getting smaller. That's the change in this pattern. But I'm going from 20, 18, 16, something, 12, 10. You think you know what it is? I can tell that it's decreasing by 2. I also know how to skip count by 2. So if I do that backwards, 20, 18, 16, what's missing here? 14. You got it. So the rule of the pattern was -2. We were given all of our numbers except one that we had to figure out. And remember, that might be right in the very middle. Okay, one last number pattern, then we're moving on. In this number pattern, let's see what happens. Okay, I see that it's growing. My values are increasing. So 1 to 2 is +1. 2 to 4, let's apply that +1. It should be, oh, wait a minute. 2 plus 1 is 3. And the next number in my pattern is 4. Wow, I really need to go back and look at this. So I can tell, I know from 1 to 2 is +1. What happens from 2 to 4? It's +2. Do you see that? 2 plus 2 more gets me 4. Well, what happens between 4 and 7? Is it +2? Well, 4, 5, 6. No, that only gets me to 6. 4, 5, 6, 7. Ooh, that's a +3. Wait a minute. +1, +2, +3. Could this be a +4? Well, 7, and I have to get to here. 8, 9, 10, 11. I think I have it now. So that is a +4. So my pattern in my numbers down here is growing also. +1, +2, +3, +4. Do you all think this is going to be a +5? I do. So 11, 12, 13, 14, 15, 16. Yep, +5. So from 16 to this next number that we have to figure out, what do you think it's going to be? A +6. Good job. You've nailed it. 1, 2, 3, 4, 5, 6. So what is 16 plus 6? I'm giving you a second to think. Whether you're counting on from 16 or using another strategy, did you come up with 22? You got it. So check out what's happening here. You can see the increase in the number values along the bottom as you see the increase in the number pattern too. That's another thing to look for in our growing number patterns. Great job with that so far. Let's now look at growing patterns with pictures. So when you have growing patterns with pictures, one thing stays the same. Can you see the trunk of this tree stays the same? But in the first term, we only have one level of the tree. In the second term, we have 2 levels. And the third term, we have 3 levels. How many levels do you think we'll have in the fourth term? If you can see that it's increasing by 1 and you think we'll have 4, I think you are exactly right. So the fourth term of this pattern, and look, I need to do this so I can go off my paper so you can see it, would look like this, where it would increase by 1 each time. That's what a picture growing pattern looks like. Here is another one. So let's check out this caterpillar. You can see his head is the constant. That's the thing that stays the same. but his body is what's growing. So in our first term, he has 1 in his body. In the second term, he has 3. 1, 2, 3. In the third term, he has 1, 2, 3, 4, 5. So if there's a +2 between all of these, how many do you think we should draw out for this term, for the fourth term? 1 + 2 is 3. 3 + 2 is 5. 5 + 2 is, you got it, 7. 1, 2, 3, 4, 5, 6, 7. That is what the next term in this growing picture pattern should look like. Way to go, third grade. One more. All right, so we got a train. We have something that is constant. That's the engine of the train. All right. How many parts of the train are here in term 1? 0. How many are in term 2? 2. How many are in term 3? 1, 2, 3, 4. So 0, 2, 4. What do you think? Do you hear the skip counting by 2s? I think this is going to be 6 as well. Do you also see that 0 + 2 is 2? 2 + 2 is 4. 4 + 2 is 6. So this is where I'd put 1, 2, 3, 4, 5, 6 to complete this picture pattern. Nice job. All right. In picture patterns, you may also see tables, in and out boxes. You might hear them called function tables. Well, we are going to do a little bit of work with those too, and then finish up with one last thing, which is objects. So let's check this out. This is what is called a function table, or an in and out box. This is where we see patterns in numbers. Now, I want to show you something. The connection between the numbers goes from the in box to the out box, not going down the inside in portion and then out and then going down the out portion, but across from in, out, in, out, in, out, in, out. So for function tables or in and out boxes, you have a rule. Sometimes you're given the rule and sometimes you have to figure out the rule. Well, this one, we are given the rule, and the rule is to add 4. So if you put 4 on the inside of the function table, 8 comes out. 5 we have to figure out. But look, here's the add 4 rule down here. If you put 8 in and you add 4, 12 comes out. This one we have to figure out also. So let's go back up to our rule, which is add 4. And I have put 5 in. What's going to come out? What is 5 plus 4? Let's get rid of that question mark and make a 9. You got it. Let's go down here to 16. If I put 16 in and I add 4, what's going to come on the out portion of my in and out table, or my function table? You got it. 20. Nice job. Let's look at another one. Here we have the same thing. I see some question marks down here we have to figure out, but let's look at what we have. We have the in portion, the out portion, the connection between these two numbers, and my rule is telling me what? Subtract 3. So if 15 goes in, I subtract 3, 12 comes out. If 23 goes in and I subtract 3, 20 comes out. If 16 goes in and I subtract 3, what's going to come out? Not a question mark, but 13. Good job. If 10 goes in and I subtract 3, 7. Way to go, third grade. Let's look at another one. This one, let's try and figure out what the rule is. We also have a question mark down here, but I think we can do it. So if 5 goes in, 10 comes out. Ooh, I see an increase between here and here. So that lets me know it's plus something. I'm going to get rid of my question mark. It's add something. Let's see if I can finish. 15 goes in, 20 comes out, 35 goes in, 40 comes out. From 5 to 10, and I know this from skip counting by 5s, is a plus 5. From 15 to 20 is a plus 5. From 35 to 40 is a plus 5. I think you've got it too. So what do we need here to fill in? 60 plus 5 is 65. Nice job, third grade. So we have not only figured out what the rule is by looking at the relationships in our in and out boxes, but we have figured out that last number also. So sometimes in an in and out box, you might actually have to solve a problem. So let's check out what's going on here with Sam. Sam has a bicycle shop. How many bicycle tires are there on 8 bikes? Well, let's figure it out. I know that my relationship comes from what's on the in to what comes out. So, or what goes in to what comes out. If I have 1 bike, I have 2 tires. If I have 2 bikes, I have 4 tires. If I have 6 bikes, I have 12 tires. My rule up here is telling me that I need to double, because 1 doubled is 2. 2 doubled is 4. 6 doubled is 12. So let's get rid of this question mark and figure out how many bicycle tires Sam would have on 8 bikes. What is 8 doubled? Perfect. 16. Way to go. We have one more thing to talk about with our growing patterns, and then I will sign off for today. So hang in there with me, all right, third grade? One last thing. So in growing patterns, you might also see objects. Actually, I'm going to move my paper for right now. You might also see objects. So I'm going to start building a growing pattern with objects. Here, oh goodness, let me slide that down. You couldn't see that at all. Here is the first term. Here is the second term. Can you see it growing already? Can you see what the change is between here and here? Here's the third term. You think you know what's going to happen? I bet you do. There's the third term. Here's the fourth term. And what we're going to do next with this object pattern is we are going to transfer it. And by transfer, I'm going to take what I've already figured out in one pattern and I'm going to put it in another pattern. We're just going to transfer this pattern to a number pattern and see if we could figure out what would come next. Okay, so let me get my paper back. I'm going to fold it over really quickly so we have room. So look, you can see the pattern growing, right? Now I'm going to transfer these objects into numbers. How many is in the first term? 3. How many is in the second term? Well, let's count. I know there's 1, 2, 3, 4, 5, 6. How many is in the fourth term? Well, I know this much of it is 6 because it's the same as this. So 6, 7, 8, 9, 10. All right, how many is in the fourth term? Well, I know that much of it is 10 plus how much? 11, 12, 13, 14, 15. Okay, so let's see what we have going on so far. From 3 to 6 is a plus 3. From 6 to 10 is plus 4. From 10 to 15 is plus 5. Good. Do you see the plus 3, plus 4, plus 5? Do you think in the next step it would be a plus 6? I do. So what is 15 plus 6? You got it. It's 21. The fifth term of this growing object pattern would have 21 little blocks to make it. We figured that out because we transferred it from the objects to numbers and we followed our pattern. To close our video today, let's prove it. All right, I've run out of room over here on the side, so I'm gonna build the fifth term of this growing pattern right here. And let's see if we were right. Let's see if it has 21. All right, we're going to finish up really quick. So there's what it was in the first term, the second term, the third term, this is the same as this, the fourth term, and here we are in the fifth term. All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right, way to go, third grade. You've worked really hard with me during this video today. We have talked about our growing patterns and objects and pictures and numbers and tables. And when I say tables, I mean those in and out boxes, or we called them function tables. I want you to start noticing growing patterns all around you. And believe it or not, the reason that you're learning this today is because this stuff is going to help you when you get to algebra in middle school or high school. So hang in there, third grade. Keep working those big, beautiful math brains, and I look forward to doing another math video with you really soon.